This lecture, we are going to implement or stack and write the same program that we wrote before, this time using a stack to give you the benefits of it. The first thing that we need to do is to put a register inside the CPU. We call it SP, having one job to contain the address of the top of the stack. As we go along, as I said, these abstractions would make much more sense. So it would contain an address of a memory cell in the memory. Since the addresses are 16 bits long, therefore the length of the SP should be equal to 16 bits. That's why I'm showing the SP longer as the other registers. In our example, we are saying that the addresses are 16 bits long, and these addresses are all in hex. And I'm just not saying 0015, but you know the addresses are actually created using 4 hexadecimal digits. The other thing that we need to do is to implement two instructions, push and pop, to work in conjunction with the SP or stack pointer register. So if I say push, it might take an argument, and in the example that we are using, it might have like the 02. Again, as I said, I'm just giving you the idea of a stack. It's not restricted in 8085. As we go in the next lecture, you'd see the exact code that we use for the 8085. So push, in our example, the argument could be 8 bits. I could say push 02 or push A. Push A would mean the contents of the A register. Push 02 would mean push the value of 02. And again, in our example, these are encoded using 8 bits, meaning 02 would be 00000010. Two operations would be done when we say push something. The first operation would be decrementing the SP by 1. SP minus 1 should go into SP, means that we are decrementing the value of SP. Then we say move whatever is the argument to the location in memory that SP is pointing to. The other one is pop. Pop again would get one argument like pop B. This pop B means two operations. First, move whatever SP is currently pointing to, whatever the memory cell that SP contains its address, to the argument of pop, which in this example is B register. So pop, the argument of pop is actually a destination. Then increment the SP by 1. Now let's see how pop, push, and SP register together would implement something called a stack, which is super useful for the programmer to write their program. So the first thing that we need to do is to load the register SP by a value that we want it to represent our top of the stack. I want the value, the address of 15, to be my top of a stack. So I say move the value of 15 inside the SP register. You see, if in 8085 you want to do it, you say LXI SP and 0015. It doesn't mean that the transfer is between the CPU and memory. It is a transfer, the 0015, inside the CPU in the SP register. Nothing has been done between the CPU or register or memory yet. So now SP, we have the value of 0015, or in binary it would be 0000, 0000, 0101, or in the decimal it would be 21. But for simplicity, I'm just showing the value of 15 in the SP, but you know it has been encoded using 16-bit and it is in the hex. Next thing I want to say, we want to implement this operation, right? So we say push the value of 02, which would be the contents of the A variable. So again, this push 02 would mean two operations should be done. First, decrement the SP. So SP should be equal to 14. Then move the value, the argument of the push, inside whatever memory location that SP is pointing to. SP is pointing to location 14, so the argument of push is 02. 02 would be written in the memory location 14. Then we say now push the next value, which is 5. Push the value of 05 again. The first operation is increment the SP. So SP would be equal to 13. Now it is pointing to this location. Next operation is move whatever the argument is in the location that SP is pointing to. So 05 would be moved to this location that SP is pointing to. After that, we say pop to the B register. Meaning the first operation of pop, move whatever the SP is pointing to, the contents of the memory cell that SP is pointing to the argument of pop, which is B register. SP is pointing to the memory location 13, so 05 should be moved inside the B register. Then the other operation is that increment the SP register. So 13 should be equal to 14. We say now SP, the top of the stack, is actually 14. After that, we just say add B, which would cause the addition of A. No, actually, we should also load the value of the A register as well. So we say pop A. What pop A means, again, the same thing, the same two operations. Move whatever SP is pointing to the argument of pop, which in this example is A. So SP is pointing to the location 14. Register A should be loaded with this value 02 and then increment the SP. Therefore, SP would now be equal to 15. And this is our top of the stack. Now we add them. Add B would mean A plus B should go inside the A. So 02, the A register, would be overwritten by their addition, which would be 7. First, we need to save the value of A register. So we say push the A register. We said that in our example, it could be immediate data or register. Later, you'd know that in the 85, it's only actually a 16-bit register. So push A would, again, the same two operations, look whatever the SP is pointing to, first decrement the value. 15 would be decremented, so we have 14. Now move whatever the argument of push is inside whatever SP is pointing to. SP is pointing to the location 14. Its argument is the A register, which is 07, so 07 would be moved inside memory cell 14. After that, we say push. So the first operation has been done, A plus B, and its result has been saved in a memory cell. Then we want to move the C and D variable. So I say push 06, the same operations. First, SP should be decremented by 1. 14 would be 13. So our top of a stack is now 13 memory cell. And then move the argument to whatever SP is pointing to. The argument is 06. So 05 would be overwritten with the new value of 06. Then we move the next value, which is 9. So I say push the 09, the same operations. Look at SP, decrement it. 13 should be decremented to 12. This is now our top of the stack. Now move the argument to whatever SP is pointing to. The argument is 09, right? So 09 would be written inside the memory location 12. Now we have C plus D. We need to bring them in the A and B register. So what I say is that pop to the B register, pop would have these two operations. First, move whatever SP is pointing to the memory cell, to the register B, or to the argument of the pop. Argument of the pop is B register, and whatever SP is pointing to, because SP is 12, it's 09. So 09 would be moved inside the B register. And then the second operation, increment the SP. SP would be incremented to 13. So top of the stack has been changed to 13. Then pop A. Again, the same two operations. First, move whatever SP is pointing to the argument of the pop. Argument of the pop is A. Whatever SP is pointing to is 06. So 06 would be moved inside the A register. And then the next operation, increment the value of the SP by 1. So SP would be equal to 14. Now this would be our top of the stack. Then we just say add B again. A plus B would be moved to the A register. So we would have 09 plus 06. The A register would be loaded with the, or overwritten with the value of 15. Now, what we want to do is to finally, you see, add doesn't have any effect on the top of the stack or on SP. The only operation that we are working with and they have effect on the SP are either push or pop, even though we could also use this operation to load the SP with new values. So right now we want to multiply them, but the first thing that we need to do is to bring the result of the previous operation. What we do is not to work with any memory address. We just simply say pop B. What does this pop do? You see, we don't need to know where we saved it. We say pop B. Now, what is the location that SP is pointing to is 14. What this pop does, move that value that SP is pointing to the argument of the pop, which is B. SP is pointing to the location of 14. You see it's 14. Move that value inside the B register. So you would have 07 in B. And then finally we say, now do the multiplication, and 7 would be multiplied with A, and the result would be saved here, which would be 105. No other values are changing. And right now, because we said pop, the first operation was this, the second operation before mul, I forgot to increment it. So now SP is pointing to 15, right? So SP is pointing to 15. Now, let's analyze what has been done here. You could also save the value of A now in the location of 15 by just saying another push. But let's see what was the difference between this program and the previous one. The previous one were a lot of moving and taking care of different addresses by the programmer, but here the programmer hasn't done any addresses. The only thing that the programmer would do is to load the SP with a location, nothing else, just push and pop. He doesn't need to remember when he saved the A plus B. It's just the same operation, push, pop, push, pop. The only thing is that they should care about the number of push and pops, and only using 3 memory cells. All of these things have been done, less memory and more speed, and also the simplicity in writing the program. You only need to, and I think you now know what the stack does, that it makes it this powerful, is that in the push, first SP is incremented, then moving happens. In the pop, it's the other way around. So by just taking care, by just caring about push and pop, you could easily write your own program without ever needing to take care of which memory cells are free or which are not. You just write the push and pop in this way without needing to understanding the empty memory cells. Now, in the next lecture, now that you know the idea of the stack and why it is useful, again, we call SP pop and push, or a stack. A stack is not something special, it's just the content of the SP. Whatever you want the SP to be, the top of the stack, that is the definition of the stack. It's just a way of you looking at a specific memory range or memory cells. It's not something physical, it's in your mind as a programmer. So this was it. In the next lecture, we are going to talk about the specific operations that are in AT85.